Welcome all. In this lecture, we will discuss some fundamentals of AC waveforms. So consider a sinusoidal AC waveform A equal to AM sine theta. So AM is the maximum value and theta is the angle. So if theta is varied from 0 to 360 degree or 0 to 2 pi radian, if it is in radian, if theta is varied from 0 to 2 pi, we will get a waveform. This is a AC waveform. It is alternating. It has positive cycle and negative cycle. So it is a alternating current waveform where theta is varied from 0, pi by 6, pi by 3, pi by 2. It will be maximum. Sine pi by 2 is AM. So it will be maximum value. Again at pi radian, sine pi is 0, it will be 0. Again it will be repeating negative f at 2 pi is again 0, completing one cycle. So now we can define some important terms related to AC waveform. First one is amplitude. So amplitude is the maximum value attained by the AC quantity. So if you are looking here at pi by 2, sine pi by 2 is AM. So it is the maximum value. So AM is the maximum value here. So it is the amplitude, or it is also called maximum value or peak value. Next one is instantaneous value. So if you are looking here, for an AC quantity, the value at each instant is different. So at any instant, if you are focusing the value, it is called the instantaneous value. Value of AC quantity at any instant is the instantaneous value. Next one is time period. Time period is, so we told that in AC, this is one set or one cycle. Okay, this cycle will be repeating. After this also it will be repeating, the positive and negative will be coming. Okay, so it will be repeating. Okay, so this called one cycle. So the time taken to complete one cycle is called time period. Means this one from here to here, this time is called time period. Next one is frequency. Frequency means, so we told that this is one cycle. It is completed in t seconds or time period. It is the time period. So number of cycles in 1 second is called frequency. Time period is the time taken by AC quantity to complete one cycle, where frequency is the number of cycles in 1 second. Its unit is hertz. So we told that frequency is the number of cycles in 1 second. Okay, or we can term like this: time taken by AC quantity to complete F cycle is 1 second. Okay. We can term like this, or if from this we can find the time taken to complete one cycle. So this is for F cycles. For F cycle it is 1 second. So for one cycle it is 1 by F. Okay, 1 by F. So time taken by AC quantity to complete one cycle is 1 by seconds. But time taken to one cycle is called time period T. So we can say that T is equal to 1 by F. So this is the relation between time period and frequency. So frequency is the reciprocal of time period. So next, so this is A equal to M sin theta, where theta is actually the angular displacements. For say 0, pi by 6, pi by 3. So angular, there is some angle displacement. So the value is changing. Okay, so theta is actually the angular displacement. Okay. So again, if you are defining another term, angular frequency, it is the angular displacement per unit time. Means angular displacement is actually theta. So omega is actually theta by t. Omega equal to theta by t. So this is called angular frequency. So again, if you are looking here at here theta is varying, t is varying. Okay. So at theta equal to 2 pi. So here, this is the time taken is actually capital T. So at theta equal to 2 pi, T is capital T. So substituting this here, omega equal to 2 pi by T. So omega is actually a constant for a waveform, sine waveform. Again, T is the 1 by F, reciprocal of frequency. So we can write as omega equal to 2 pi F. Means that is why it is called angular frequency. So for a particular AC waveform, omega is constant. It is only depending upon the frequency. Again, if here we can write theta as omega t. So substituting theta equal to omega t, we can write the AC waveform as A equal to AM sine omega t, where omega t is varying according to t, time. Omega is a constant, only depending upon the frequency. If we are varying the t, this angle will be varying and the AC waveform can be plotted. Means it becomes the function of time. Now omega t is varying from 0 to 2 pi. Omega t is theta. So again we can plot like this with respect to omega t. Okay, fine. Then we can discuss RMS and average values of AC waveforms. So RMS value, root mean square value, RMS value. So RMS value is the effective value of a varying voltage or current. So if you are considering AC, the value of AC is not constant like DC. So for a DC, it is clearly understood there will be only one quantity or one value. At any time the value will be a constant. Okay. So in case of AC, it is not constant. So RMS values is a constant value. RMS value is a constant value that will show the effective value of this AC. Means if you are flowing a DC value through a resistor, it will absorb some power. And in case of AC, if you are flowing that AC through this resistor, and DC value, the RMS value is that value which that absorb the same power in this resistor. Okay, or it is the equivalent steady DC value that absorb the same power in a resistor. That is a DC current. Okay. Then average value. The average of all instance values of an AC waveform over one cycle is called average value. So we can calculate the RMS and average value by this equation. RMS value by or average value by 1 by t 0 to t f of t dt. So this will give the summation of instance values integral 0 to t f of t, one cycle, 1 by t the average. And RMS value means root of mean of square. So first we have to square the instance value, then we have to take the mean. Mean means we have to add all values by 1 by t. So that will mean, then square root. Root means square. So 1 by t, root of 1 by t, integral 0 to t f of t square dt. And now we can find the RMS and average value of a AC sine wave. So we know RMS value is equal to root of 1 by t 0 to t f of t whole square t dt with respect to t. Now if this is the waveform, A equal to, or A is the function of theta, am sine theta. Theta is varying from 0 to 2 pi. So since here it is function of t, here it is theta. So we can write RMS values as 1 by t 0 to t A of theta. Okay, here the function is with respect to theta, of theta square d theta. So we have to integrate with respect to theta. Then we can substitute t. T is the time period. So the time period is 2 pi radian. So t is 2 pi. A of theta is am sin theta. So we can write as 1 by 2 root of 1 by 2 pi integral 0 to 2 pi. A of theta is am sin theta square d theta. Again we can split this as am square sin square theta. Again we can take outside this am square. It is a constant, so we don't want to integrate it. So am square by 2 pi integral 0 to 2 pi sin square theta d theta. So in order to integrate, we have to convert this. So sin square theta is actually 1 minus cos 2 theta by 2. So we can substitute sin square theta as 1 minus cos 2 theta by 2. So again we can take 2 outside. It is a constant. And while integrating, 1 is constant, so integral is theta, cos 2 theta, integral is sin 2 theta by 2, and we have to give the limits as 0 and 2 pi. Then giving the limits we will get 2 pi, so upper limit is 2 pi, here sin 2 pi is 0, lower limit is 0 and 0, so only 2 pi here. So it has am square by 2. So root of am square by 2 is am by root 2. So RMS value of a AC sine wave is am by root 2, maximum value by root 2. Next we can find the average value. So equation for finding average value is 1 by t 0 to t f of t dt. So if you are considering this waveform a of theta equal to am sin theta, we have to replace t by theta, the function with respect to d theta. So if you are looking here this cycle and this cycle are symmetrical, so the sum of these values will be equal to sum of this value but negative, so the sum will be actually cancelling. Okay, it will be 0, so average value is actually 0, but we will be finding the average value by finding the average with respect to a half cycle. Okay, for a half cycle 0 to pi, so we are actually finding average for t by 2 only. So 1 by t by 2 0 to t by 2 a of theta d theta. In t is 2 pi, a of theta is am sin theta, so we get 1 by integral 0 to pi. T is 2 pi, so t by 2 is pi, am sin theta. Again am is constant, so am by pi integral sin theta. Integral sin theta is minus cos theta, limits are 0 and pi. While giving the limits is minus cos pi plus minus this minus cos 0 is 1, so 1 plus 1 2 am by pi. So average value of sine is 2 am by pi. So for a sine wave RMS value is am by root 2, average value is 2 am by pi, or am is the maximum value of the AC sine wave. Next is peak factor. Peak factor is the ratio of maximum value to RMS value of an AC quantity. It's also called amplitude factor or plus factor. Kp is equal to maximum value by RMS value. But for a sine wave, RMS value is 2 am by pi. So we can write as Kp equal to maximum value is am by root 2. So we will be getting as root 2 or 1.414. For sine wave, peak factor is 1.414. Similarly, another term is form factor. Form factor Kf is the ratio of maximum value to RMS value. Kf is RMS value by average value. For sine wave, RMS value is am by root 2 and average value is 2 am by pi. So we will get as pi by 2 root 2. It's actually 1.11. So for sine wave, peak factor is 1.414, form factor is 1.11. Next term is phase. So for a sine wave, a equal to am sin omega t, it will be like this. The plot will be like this. It will be starting from 0. At omega t equal to 0, the value is 0. And at omega t equal to pi by 2 is am. Again at pi it is 0. Then here it is 3 pi by 2, it is minus am. And again 2 pi it is 0. So this is the waveform for a equal to am sin omega t. So if this waveform is shifted to left side, okay, say by a 5 degree, okay, it is starting earlier, a 5 degree earlier. Okay, so at this point here, if you are looking at t equal to 0, the value is not 0. Okay, it's actually sine phi. At t equal to 0, it is actually sine phi because of this phi. So the function is a equal to am sin omega t plus phi. There will be a plus phi here. Okay, here also that will be reaching this 0 earlier. Okay, this 0 also earlier, a 5 degree earlier. Again, if you are considering like this, it is shifted to right side. Okay, so it is delayed, okay, or at this point t equal to 0 it is not reaching 0, okay, it is still at negative cycle. It is actually sin omega t minus 5. Okay, it is here it is the value is sin minus 5. Okay, so we can represent a equal to am sin omega t minus 5. If it is shifted to left, if it is early, it is called omega t plus 5. If it is delayed, it is called, or shifted to right side, it is omega t minus 5. So here the phase angle is 0. It is starting from 0 itself. Here it is phase angle is plus 5. Okay, here it is minus 5. Or this is called leading by angle 5. This is called lagging by angle 5. Okay, so this is the phase or phase angle. We can represent the sign by this with the phase angle also. Again, we can represent AC voltage and current also using sine waves. So here voltage is starting from 0. Its maximum value is Vm. Okay. So we want to represent the or write the equation for the AC. We need the starting point, then maximum value, and the omega. So V is actually Vm sin omega t. V is the maximum value, omega is the angular frequency, and it is starting from 0, so no phase angle, so sin omega t itself. And if you are looking current is starting 30-degree delayed or lagging. Okay, so it is starting from here only, 5, after a 5 degree. Okay, so it is lagging. Okay, so here also there will be maximum value will be different, Im. Okay, so I is equal to Im sin omega t minus 5. So for any AC quantity, in order to write the equation, we need only the maximum value and the omega, and if there is any phase difference at phase also. If it is delayed, it is lagging minus 5. If it is earlier, it is leading plus 5. Okay. So with this we can wind up the session. Thank you.